Hey, what's up everybody? My name is Moss, and in this video, I'm going to show you how to configure the Prometheus receiver in the OpenTelemetry Collector and push Prometheus metrics to Splunk Observability Cloud. What is the Prometheus receiver and why would you want to use it? It enables the OpenTelemetry Collector to scrape Prometheus endpoints without requiring an independent Prometheus server. Using the Prometheus receiver, you're able to centralize ingestion, enrichment, and export of Prometheus metrics to Splunk Observability Cloud. And the receiver works with any Prometheus-compatible target, such as custom apps or exporters. In this video, I'll demonstrate the receiver using several data sources. The first data source will be a custom Python Flask application exposing a metrics endpoint using the Flask exporter. We'll also use the NGINX Prometheus exporter to push basic NGINX metrics to Splunk Observability Cloud. And one thing I'll point out is that there is an independent NGINX receiver that you can use in your OpenTelemetry Collector configuration. But if you're already using Prometheus to export your NGINX metrics, then this would just be a minimal path to integrate it with your OpenTelemetry Collector configuration. And finally, the last data source is using Node Exporter to export host and system metrics. Similar to NGINX, there is a dedicated host metrics receiver that you could utilize, but if you're already using Prometheus with Node Exporter, then this would be one of the paths that you could use to centralize your configuration in the OTel collector. We'll also add resource tags to those Prometheus metrics so that when we send them to Splunk Observability Cloud, they'll be easy to filter on. In Splunk Observability Cloud, we'll create some quick charts for request rate and average node load. Now that we've covered a high-level overview, let's get started with the demo. So the first configuration that I want to cover is when we're using Prometheus with a custom-built application. And in this case, we have a simple Python application that's using the Prometheus Flask exporter. So I'll show the application code real quickly, and then we'll jump to the OpenTelemetry configuration file. At the top here, we initialize the Prometheus metrics class and pass in the path for exposing Prometheus metrics, which is just the metrics endpoint. We also define an informational metric called app info, which includes the service name, and we're calling that Prom Flask. Now, if I scroll down here to the checkout endpoint, this is going to be the primary endpoint that we'll hit, and this endpoint simulates several scenarios. The first scenario is a high latency scenario that has a 10% chance of hitting when you make a request to this application's checkout endpoint. The second scenario is an error scenario that also has a 10% chance of happening. And the third scenario here is just normal operation. So let's take a look at the OTel collector configuration file to see how do we define the Prometheus receiver to scrape metrics from that metrics endpoint. So at the top of our configuration file, we define receivers, and then starting on line 2, we define the first Prometheus receiver, and we give it a custom name. So this receiver is going to be called Prometheus/Flask. And then we define the configuration for that receiver, which includes the scrape configs. And we're only defining a single job that has a name of demo-app with that metrics endpoint that we define in the application. Our scrape interval is going to be 5 seconds. And then the target is the demo app on port 5000. The target's value is an array, so if we did have multiple hosts with that metrics endpoint, we could include them in this array. Now let's scroll down to the processors. Now under the processors, we define resources, and the first resource that we define is called Flask. And there's several attributes that we add to this resource. So what we're doing here is we're going to be enriching and standardizing the attributes that are associated with the Flask application's metric data. And we're doing that by defining attributes with key value pairs. The first attribute that we're adding is service name, and we're setting that value to prom-flask. The second is the service namespace, and we're calling that prom-demo. And then the last one here is the deployment environment, which we're setting to Moss demo environment. And doing this allows us to really easily filter on the metrics generated from this Python application based off of these values or these key value pairs in Splunk Observability Cloud. Now, if I scroll down to the exporters, we have a single exporter here to export our telemetry data and our metrics data to Splunk Observability Cloud using the SignalFX exporter. So all we have to do is pass in the access token and then the realm that we want to export data to. We're also using the debug exporter. None of the processors, receivers, or exporters are active until we put them in pipelines. And so if we scroll down to line 70, we're defining pipelines, and the first pipeline that we're defining is a metrics pipeline, and we're calling it Flask. So this is going to be a dedicated pipeline specifically for the metrics associated with the Flask application. And here we're including that Prometheus Flask receiver, the resource, the Flask resource, and we're also adding the batch processor. And then finally, we're exporting to Splunk Observability Cloud. And we're going to use this pattern for all three data sources. This structure is a little naive because we're kind of duplicating a lot of logic here, but for clarity's sake, I am separating out the pipelines. I'm also separating out the Prometheus receivers because it's easier to understand rather than adding conditional logic in processors so that we have maybe like one pipeline. But in a production environment, I would probably expect that you would consolidate all of these pipelines into a single pipeline and then add a conditional logic in the processors so that you could also consolidate the pipelines and the receivers. Now, if we take a look at the Docker desktop application, I've already deployed the Docker Compose stack with all of the applications that we want to pull Prometheus metrics from. And you can see here in the demo app, the Python Flask application is this demo app 1. Okay, and then we also have the OTel collector running. What I'm going to do is generate some traffic for that Flask application, and then we'll take a look at Splunk Observability Cloud. Okay, so I'm generating some traffic with 25 requests, and remember that not all of the requests will succeed. We'll get some errors as well. Okay, so we have a 24% error rate on those 25 requests. Now let's navigate to Splunk Observability Cloud. From the home page, I can see all of the Prometheus metrics by using the metric finder. And in the search bar, I can search or filter on various attributes that I've associated with those metrics. So remember that I created a service name attribute and appended it to the metric data, okay, as a processor, a resource processor. So we should be able to filter on that resource by using service.name : and then the application that I want to filter on is prom-flask, okay? That was a service name that we defined inside of the application code. Now I can see 21 Prometheus metrics for that Flask application. I can continue to filter based off of the path, the histogram bucket size, or the status code. The metric that I want to see is the Flask HTTP request total. Its metric type is a cumulative counter. When I click on the metric though, it generates a chart where I can see requests over time. And not only that, if I look at the data table, it automatically groups them by the status codes. Even though it's a counter, we immediately get a valuable chart when we push this metric data to Splunk Observability Cloud. And then, I could make this, I could change the name of this chart to, Flask app request rate. And save that chart and then put it in a new dashboard. If I wanted to add more charts to this dashboard, I can actually browse metrics within context of the dashboard. Or if I wanted to edit the chart before adding it to the dashboard, I can select New Chart here. And this gives me a little bit more control on the queries. And if I select Browse, I'll select Python info. I'll select table. And then we can get the Python information that we defined inside of the application code. I'm going to go back to Metric Finder. Let's navigate back to our code editor. Okay, so the next data source that I want to cover is Node Exporter. So a lot of times you want to monitor host or system metrics. You would use Node Exporter to expose those system metrics, and then Prometheus would scrape those metrics. It's a very common use case, and we can actually configure the Prometheus receiver to scrape Node Exporter metrics. If we take a look at this Docker Compose file, I'm actually deploying the Node Exporter image to this Docker Compose stack, and then we're exposing it on port 9100. Okay, so nothing special there. If we go to the OTel collector configuration file, like I said before, we're following a very similar pattern as we did with the Flask application. On line 10, we define a new Prometheus receiver, give it a name of node, and then we define the scrape configuration, and that job name is called Node Exporter. The scrape interval is 10 seconds, and then the target is the name of the Docker service, which is Node Exporter on port 9100. If I scroll down to the processors, there is a resource that I'm defining specifically for Node. And so we have this resource called Node, and then the attributes that we're adding are the same keys that we added for the Flask application, but with different values. Really, the only unique value here is the service name, which is going to be Node Exporter. The other two are the same, and you could argue that we could create like one shared resource and then add that to all of our pipelines. But again, just for clarity, I am taking this naive approach to have them individually defined. And then if I scroll down, we have a dedicated metrics pipeline for Node Exporter, where we are including the Prometheus node receiver, the resource, the Node Exporter resource, and then exporting to Splunk Observability Cloud. Now, obviously for this pipeline, since it's just system metrics, we're constantly getting data pushed to Splunk Observability Cloud. We don't necessarily need to generate traffic to see the data in Splunk Observability Cloud. And just to validate what our runtime environment looks like, in Docker Desktop, we have one Node Exporter container running, and then we have the OTel collector. So let me open up Splunk Observability Cloud again, and this time we are going to filter on the service name, but for Node Exporter. Okay, so Node Exporter. And then we have a lot of available metrics related to our host that we could create charts for. One that I always find useful is load, average load for 1 minute, 5 minute, and 15-minute time ranges. So I'll just search for load. And there we can see node load over 1 minute, over 5 minutes, and the 15-minute load average. Okay, and we could add all three of these metrics to a single chart. So if I select node load 1, we get a chart with just the average load over 1 minute, and then I can add the other 5-minute load average and the 15-minute load average down here. And then those are overlaid. And we can also, these are the same color, but to make it easier to view, we can change the color so that it's a little bit easier to read. I'm not going to add this chart to a dashboard. I'll just navigate back to our code editor. And for our last data source, we are using an NGINX server. And on that NGINX server, we're simply configuring it to listen on port 8080. And when we hit the root endpoint, we're just going to return 200 and OK. We're also exposing this stub status location. And this endpoint is what the NGINX Prometheus exporter is going to be scraping. So let's take a look at that Docker Compose file again. And if I scroll up We have NGINX listening on port 8080. And then below that, we define the NGINX Exporter service. And the key here is the command that we're passing in when running this container, which is the NGINX scrape URI. So that's going to be hitting the NGINX service, the Docker compose NGINX service on port 8080, and then that stub status endpoint. So now let's take a look at the OTel collector configuration. And I'll scroll up to the top here. If we look at the Prometheus, the last Prometheus receiver here, we're calling it NGINX, and then we're defining a scrape config with a job name called NGINX-Exporter, 10-second intervals of scraping, and then the target is the NGINX Exporter container on port 9113. If I scroll down to the processors, we have the NGINX resource that's being defined, and again, it's the same attributes, attribute keys that we were using before. The only difference is the service name, and we're giving it a unique value of NGINX Exporter so that we can filter it easily in Splunk Observability Cloud. And then I'll scroll down to the pipelines. And we're defining a dedicated metrics pipeline for NGINX. And the receivers are the Prometheus NGINX receiver, the NGINX resource that we define along with the batch processor, and then exporting to Splunk Observability Cloud. Not for all of the NGINX metrics, but for a lot of the main ones that we care about, like the request rate, we do need to generate some traffic against our NGINX server. So that's what I'm going to do. I've got a command copied to my clipboard, and I'm just going to paste it into the shell here. And this is just going to loop 10 times and make a call to a local endpoint. Originally, it was calling the custom application, but what we're going to call is just localhost on port 8080, which is our NGINX server. Okay, so that should have sent 10 requests to NGINX, and so we should be able to see some data for our metrics pushed in Splunk Observability Cloud. I'm going to filter based off of the service name, and I'll select NGINX Exporter. I'm going to filter on the request keyword. And similar to the Python Flask application, we get an NGINX request total cumulative counter. So I'm going to select this one. And similar to the Flask application, we don't have to apply the rate function to this metric, this counter metric, to see it properly rendered on a chart over time. Splunk Observability Cloud is doing that automatically for us. So as you can see, it's very easy to configure the Prometheus receiver for various types of data sources like third-party applications such as NGINX, custom applications like Python, and also node exporter system metrics. Now, as I mentioned before, there are dedicated receivers for host metrics as well as NGINX, but those metric names are not going to align with the same names as Prometheus metrics for the equivalent metric, right? So if your environment is already built on Prometheus, this might be the lowest effort path in order to consolidate your configuration, your Prometheus configuration, into the OTel collector's configuration file. Here are some of the key takeaways from our demonstration. The collector scrapes Prometheus endpoints directly, so you don't have to run an independent Prometheus server. And it acts as a single ingestion plane, so you can add or remove scrape targets centrally in one configuration file. Common exporters like Node Exporter and the NGINX Prometheus Exporter work right out of the box. And consistent resource tags like the service name make filtering and grouping straightforward in Splunk Observability Cloud. And it's flexible. You can add new scrape targets and make tweaks in the collector config instead of changing exporter container configuration or application code. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. And if you're interested in trying Splunk Observability Cloud yourself, you can navigate to this link to claim your free 14-day trial. Thanks for watching.